Welcome to the third lecture on computer networks. In the previous lecture, we talked about various challenges or design issues related to computer networks. In this session, we will talk about what is layered design, and we will start with OSI reference model. In the previous lecture, I had mentioned about challenges in the design of computer networks. I have listed some of the challenges. Say, first one is addressing. I said that for two computers to communicate, each of them should have an address. Without address, communication is not possible. And that issue is solved in practice with the use of IP address, MAC address, and port numbers. Second challenge was pathfinding. And pathfinding means that to send a packet from source to destination, a path should be available and the packet will travel through that path and will reach the destination. And that issue is known as routing problem. And there are many routing algorithms available in literature. Third issue is, say, corrupted packets. So when a packet is sent from source to destination, sometimes due to noise, some bits change. Ones become zeros and zeros become ones. And so source sends something but receiver receives another thing. The packet content changes. Likewise, there were many challenges. Now, for each challenge, there are certain solutions available, and the solutions are implemented as mentioned here. They are implemented in hardware or in software. So, every solution is basically an algorithm, and that algorithm is implemented using some software or some hardware. And we collectively, these softwares and hardwares, they are known as network entities. That means that there are a large number of network entities. When there is a large number of entities, the question comes is that how can we relate these entities? How these entities interact with each other? And I have mentioned the same questions in the next slide. As I have said that there are large number of network entities, and why there are large number of network entities? Because there are so many challenges and each challenge has at least one solution, and so each solution is an entity for us. And here are the questions that how do they interact when network is made of so many hardwares and softwares? How these entities interact with each other? The second question is there a way to arrange them? If we arrange them in certain manner, then we can understand their relationship, then we can understand their interaction. And the answer to these two questions is arrange the entities in layers. And so, let us have an example of layering from real life. Consider that there are two offices. Say, this is one office, one organization. Let us name it Office 1. And then this is second office. In office 1, there are people like senior manager 1, and clerk 1. These three people are present. In office 2, senior manager 2, and clerk 2. These three people are present. And senior manager 1 wants to communicate with senior manager 2 regarding some issue. So thing is that this senior manager 1, it wants to send a message to senior manager 2, but they do not directly communicate. Senior manager 1 has subject matter in his mind. He calls manager 1 and explains him the subject matter. So now senior manager 1 has given the subject matter to manager 1. Manager 1 has received the subject matter, and now manager 1 has typed a letter which is nothing but the subject matter is explained in that letter. Manager 1 gives that letter to clerk 1. The letter is ready, typed by manager 1. What clerk 1 does, clerk 1 prepares an envelope. He puts letter into the envelope, writes from and to addresses on the envelope, and then he drops that envelope in the post box. After some days, the envelope reaches the second office. The envelope is received by clerk 2. Clerk 2 opens the envelope. He takes the letter out and gives to manager 2. Manager 2 reads the letter, understands the content, and discusses the content or subject matter with manager 2. So at this point, whatever message manager 1 wanted, that message has reached to manager 2. But if you observe the path that the message has followed, the message was originated from senior manager 1. And that message was in terms of discussion between senior manager 1 and manager 1. Manager 1 prepared the letter, and then the letter was packed in an envelope. Step number 3. On the receiver side, the journey was down to top or from bottom to top. Envelope was received, letter was taken out from envelope, and then manager 2 reads the letter. He understands the content, and then he discusses the subject matter with senior manager 2. So this is an example of layered approach. The senior managers are at highest level. The managers are at second level from top, and the clerks are at the bottom level. Let us add something more into this. I can say that manager 1 is providing service to senior manager 1. How do we represent this? We can say that manager 1 provides services to senior manager 1. So he is providing service. Similarly, clerk is providing service to manager 1. And I am hopeful that you are able to understand this. Senior manager is assigning work to manager 1. Manager 1 is doing the assigned work. So we can say manager 1 provides services to senior manager 1. Let us call this service. Clerk provides service to manager 1. What manager 1 receives from senior manager 1, from senior manager 1, manager receives some input. And based on the input, based on the commands, he does the work. Similarly, clerk 1 receives input from manager 1 and based on the input, clerk 1 does some work. So, every person, it provides service to the person at a higher level and uses the services of a person who is at the level below. Same thing is true for this setup also. So this is a real life example of layering, and layering is used everywhere, in every office, in every organization. Later, we will look at the benefits of layering. Let me explain the benefit through an example. I said that clerk 1 prepares the envelope and he drops that envelope into a post box. Right? It may happen that clerk may send that envelope through courier. Right? Third option for clerk is that do not use the envelope, draft an email and send it to clerk 2. Clerk 2 will take a printout and will give it to manager 2. The point to understand is that clerk 1 can implement his service in many different ways. He can use postal services, he can use courier, even he can use email, or he may use fax. But as long as manager 1 is satisfied with services of clerk 1, there is no problem if clerk 1 changes the way he implements his service. So the point to note is that clerk 1 can change the mode of communication without even manager 1 knowing it. It may happen that clerk 1 sends first letter through post and then in future the second letter is sent to courier. As long as both the letters reach the other office, manager 1 has no issues. So the advantage of this layered communication is that if a layer changes its implementation of service, the higher layer does not even need to know that the method of implementation has changed. But this is true as long as the provided service is satisfactory. And later we will call this advantage flexibility or ease of maintenance. Coming back to networks, as we said that there are a large number of entities. These entities are arranged in 7 layers. There is an organization known as ISO, International Standards Organization. ISO has suggested this reference model, which is known as OSI reference model, Open System Interconnection. It means that the entities present in the network can be divided into 7 layers and each layer performs certain functions. So each layer is a set of related entities. So layering is nothing, you are grouping the related entities together. But now, given this example of communication between two managers, you must be able to visualize that application layer is going to use services of presentation layer. Presentation layer will use services of session layer, and so on. In other words, physical layer will provide service to data link layer will provide services to network layer, and so on. And whatever advantage I said, that if data link layer changes its implementation of a service, as long as the required service is provided to network layer has no issue with change in implementation. Even the network layer is not knowing that how data link layer has implemented so and so service. A layer is only concerned with the service provided. As long as that service is provided, even if the implementation changes, there is no issue. So, summarizing, there are 7 layers suggested by ISO, and this 7-layer stack is known as OSI reference model. And I have noted down this important point, that layer n provides services to layer n plus 1. Now, related to OSI reference model, we have to study 3 things. First is the advantage of layered design. Second is how layers interact. And third is functions of each layer. This third topic is bit lengthy, so I cannot cover it in this video. We will look at these first 2 things, and then later we will talk about the third one, that is functions of each layer. Now, what are the advantages of layered design? So, first thing is modularity. It is like dividing a large software project into small modules, and these modules interact with each other in a predefined way. Or I can say, it is like dividing a large program into small functions, and there is a standard interface between every 2 functions. So now if you know concept of functions in programming, you must be aware that you can change a function, coding of a function, without disturbing other functions of your program. Even you can change a function and you need to compile only that function without recompiling the rest of the code. This is the benefit of modularity. Again, for the sake of clarity, I will repeat this. Modularity means dividing a large project into small modules. Divide large project into small modules. And these modules are independent. They are implemented independently. You can change a module without making changes into other modules. From programming point of view, if your project is designed in a modular way, you can maintain, you can compile one module without recompiling the remaining modules. Similarly, in this case, these 7 layers are like 7 modules. You can make changes in any one module and the remaining modules are not affected, as long as the given module provides required services to the module above it. If you make some changes in transport layer, its implementation, that's fine. You need not make changes in session layer as long as transport layer provides appropriate services to network layer, session layer. Even you need not make any change in network layer as long as transport layer uses network layer in a predefined way. And this modularity, it gives you ease of maintenance. As I have already explained this, that you can make changes in one module without affecting the remaining modules. It is also known as flexibility. Now, how do the layers interact? So, to explain the interaction between layers, let me show this OSI model. As you can see that there are 7 layers, but applications themselves, that is application softwares, they sit above application layer. So I will write software. Applications themselves are not part of application layer. And these softwares like browser or email client or FTP client, their job is to send and receive data, to send and receive messages. Say one such message is message M. An application has generated it, and let us assume that that application is running at sender side, say app 1, and message M is generated by app 1 and it is to be delivered to app 2, which is sitting at receiver 2, which is sitting at receiver machine. In between, internet is present. So as you know, we call this internet. Remember that all these 7 layers are present in source machine. They are also present in destination machine. The question will come that then what is present in the routers? In routers, bottom 3 layers are present, that is till network layer. I will come to that point at a later time, but right now we consider that application 1 has generated message M and the message is to be delivered to application 2. Application, and the second thing is that this entire OSI stack is present in sender, it is also present in receiver. In routers, only last 3 layers are present, that is physical, data link and network. Message M generated by application 1, it is given to application layer. Application layer attaches its header, we call it H7, and then the message is given to presentation layer. Presentation layer attaches its header, we call it H6. Then this entire unit is given to session layer. Session layer attaches its header H5. Again, entity goes to transport layer, it attaches header H4, network layer attaches header H3. Finally, this entire thing, it goes to data link layer. Data link layer attaches header as well as trailer. Now, it goes to physical layer where physical layer attaches its header. At this point, this entire unit is nothing, it is a group of bits. It comes out of machine and it goes in the wire. Let us call this E. So now this E goes in the wire. It passes through the internet. Finally, it reaches the destination. And at the destination, reverse journey begins. At the destination, this E E reaches the destination, and in destination's physical layer, this E is received. So what physical layer does, that it removes header H1 and gives this remaining thing from H2 to T2 to data link layer. The data link layer removes header H2 and gives H3, it also removes T2, it gives H3 to M to network layer. Network layer removes H3 and gives this H4 till M to transport layer. Transport layer removes H4 and gives the remaining portion to session layer. Session layer removes H5, gives the remaining thing to presentation layer. Presentation layer removes H6 and gives remaining thing to application layer, and application layer gives M to application 2. So if you observe, at the sender side, headers are attached, and at the receiver side, the headers are detached or removed. At the sender side, the journey of message is from top to bottom, from application layer to physical layer, and at the receiver side, the journey of message is from bottom to top, that is from physical layer to the application layer. This is how layers interact. In short, if a layer n receives something from layer n plus 1, it will attach its header and will send it downwards. If layer n receives something from layer n minus 1, it will remove header and will send the remaining thing to the higher layer. So this is how layers interact. I am sure that you will have question that how layers are implemented in the routers, what happens to a packet when it reaches a router. So all those details we will understand in the due course of time. Right now, to keep the thing simple, we will just note down that as we go from top to bottom, encapsulation or attachment occurs. As we go from bottom to top, decapsulation or detachment occurs. And why headers are added? The reason is that every layer has certain functionalities. It is offering certain services. So to implement those services, header is added to the original message which is received from higher layer. So with this, we will stop for this particular lecture, and what next? We will talk about remaining layers of OSI model. As such, we have to start from the very first layer, from top, and that is application layer. Thank you.